For the analysis, to determine the rate law, we talked about the fact that we double concentration of each reactant individually and we get a doubling of the rate. And so our rate law looks like this. Rate equals K times concentration of iodide to the first power times hydrogen peroxide concentration to the first power. They don't really need to have the exponent 1 there, but I always say put it in anyway. That reminds you and tells the reader that you actually checked and you're not just putting in concentration. The units are a little bit clunky, and to figure out the value of K, I just tell them, don't worry about the units. The units are always going to be the same because they're involving milliliters per minute in each trial, and the concentrations are molarity in each trial. The initial concentration of potassium iodide that I used is 0.20 molar. Now they have to multiply that by a dilution factor, for example 75 out of 300 or 150 out of 300, because each other solution dilutes the iodide. The hydrogen peroxide starts out as 3% by volume. They have to figure out, okay, 3%, how many milliliters, how many grams, how many moles, and so on. So that involves a little bit of calculation. I don't think that's a bad thing. And then they put in for their average of each trial, 1 through 6, the values for the rate, the average rate, the concentration for each reactant, and they solve for K. Again, I don't really care about the units as long as the units are the same in every trial. We can just stipulate they are units of K. And then we have to have the discussion, well, how close is close? How constant is constant? And that's a discussion you can have, or ask the students, what is the variance? How much difference is there in your values of K? For example, if your K value is 1.1, 1.2, 1.3, 1.4, are those close? Well, that's about a 40% difference from trial 1 to trial 4, let's say. Even though it looks fairly close, you have to have that thought in mind. What does that mean? And I'm not really concerned with what they determine, is it constant or not, as long as they have some reasonable, rational, thoughtful explanation of why they say yes, K is constant, or no, K is not constant. And the discussion of significant figures can factor in here. It's constant up to 1 decimal place, or it's constant to 2 significant figures. Those are reasonable discussions to have. This is probably the next to the last lab we do in the year. The electrolysis of potassium iodide is usually last. So this is a pretty involved lab. It's a pretty involved write-up. A lot of calculations, a lot of thought in how to set up the experiment. But nothing that they should say, oh, I never heard of that. I never heard of keeping all the other values constant and just manipulating one. Is this some kind of scientific method thing or what? So it's complicated, it's involved. This is usually the last thing we do before spring break. And then they come back and do electrochemistry, and then we're done. So there you have it, kinetics in a wash bottle.